Let's spend a few minutes talking about virtualization and virtual network components. Virtualization is a very important aspect of modern computer networking. But before we talk about what virtualization is and how it works, we first need to look at the way things have traditionally been done. In the traditional computing model, we have one operating system for each hardware device in our network. Whether it's a server or client, it doesn't matter. We have one operating system installed on one hardware device. In this example, we have our PC hardware, we have our CPU, we have our storage resources, and we have our memory resources. These three boxes represent the hardware in our PC system. In order to use these resources, these hardware resources, we have to install an operating system. It could be Windows, Linux, or even Mac OS. Regardless, we have one hardware device with its own CPU storage and memory being managed by one operating system. The operating system's role is to provide mediation services for all the applications running on that hardware device. We have application 1, application 2, application 3, and application 4. The job of the operating system is to allocate resources to these different applications running on the system. The operating system gives application 1 permission to use the CPU and assigns it a range of memory to use. It also manages access to the various storage devices in the system. The operating system does the same thing for App 2, App 3, and App 4. For example, let's say you're going to install a new server in your data center. The first thing you do is go out and buy your server hardware, then you pick an operating system, and you install that server operating system on the hardware. That instance of the operating system has full reign over all of the resources available in the server hardware. It manages RAM, processor time, storage devices, network interfaces, and so on. That's the way we've always done things in the past. However, there's a key problem with doing things this way. It's really inefficient. Generally speaking, the operating system doesn't fully utilize all of the available hardware resources in the system all of the time. This is particularly true on the server system. You'll find that much of the time, your computing resources are actually underutilized. For example, you may see your CPU utilization hovering around 10% most of the time. You may also see that your memory utilization is typically hovering at around 20%. This means excess capacity is still available to perform additional computing tasks, but is not being used and capacity is being wasted. This wasted capacity represents wasted money as well. For example, in terms of hardware resources, each of these systems is only utilizing 10 to 20% of the available hardware resources. That means 80 to 90% of each server system isn't being used. It also represents wasted money in terms of power cost. Each one of these servers uses the same amount of power regardless of whether it's being utilized at 20% or 50%. We're also spending unnecessary money to cool the data center. We have 3 different systems here generating a lot of surplus heat that has to be removed from the data center to keep all the systems from overheating and melting down. So in other words, we're using a lot of resources wastefully. But there's a way to overcome this, and that is through virtualization. Using virtualization, we pull multiple operating systems onto the same physical hardware. Remember, we have excess capacity on our computer systems. Instead of just letting it go to waste, we're going to take advantage of it by using multiple operating systems on the same physical device. Now, in order to do this, you have to employ a special type of operating system called a hypervisor in order to manage access to system resources. This hypervisor plays a special role. Notice in this diagram, we have our CPU hardware resources, our storage resources, and our memory resources associated with the system hardware, just like we had before. But instead of installing an operating system directly onto that hardware, we install a special type of operating system called hypervisor. The hypervisor has some basic characteristics of an operating system, but it doesn't provide all the functionality that you would normally get with a typical OS. There's no word processor and there's no text editor. All the hypervisor does is manage access to the CPU storage and RAM. On top of this hypervisor, we can create what are called virtual machines. These virtual machines act like a real piece of hardware, but they're not. They're emulated hardware devices created through the hypervisor. Each of these virtual machines is allocated a certain amount of CPU time. They're allocated storage space, and they're assigned a particular segment of RAM that they're allowed to use through the hypervisor. The job of the hypervisor, then, is to mediate between all these virtual machines, each with their own operating system installed, and the resources available in the hardware itself, the physical hardware. Going back to the example we looked at earlier, we now have 3 separate servers, servers 1, 2, and 3, running as virtual machines all on the same physical hardware. The role of the hypervisor then is to manage access to CPU storage and RAM for each of these virtual machines. Remember, we said earlier that server 1 only used less than 10% of the CPU at any time, so the hypervisor manages that amount of CPU allocation that server 1 needs. For server 2, the hypervisor manages how much CPU time it gets. The same is true for server 3. The hypervisor manages how much CPU time it needs. Now, if we were to calculate an average of all 3 operating systems, we would be utilizing the CPU about 30% most of the time. Will there be spikes? Yeah, just like in a real piece of hardware, there will be spikes when, for example, operating system 1 needs up to 40% of the CPU. The hypervisor manages that access. Because these spikes probably won't happen all at the same time, we're okay. The hypervisor can grant this virtual machine extra CPU time when it needs it because these other virtual machines really aren't using that much. This allows us to use hardware resources much more efficiently in a virtualization environment. The same is true for storage. Each of these operating systems can be assigned storage on the physical device. That storage can take the form of an actual hard disk drive, an entire drive. It could be a partition on a hard disk drive, or it could even just be a file on the hard disk drive. The same is also true for memory. Each of these virtual machines is assigned a certain amount of RAM they can use. Depending on the hypervisor that you're using, it could be a fixed amount of RAM, or it could be a dynamic RAM allocation, which grants extra RAM to these virtual machines as needed. So for example, let's say server 3 suddenly needs a lot of RAM for a short amount of time. The hypervisor can go ahead and dynamically assign that necessary RAM to it. When it's done, it'll reclaim that RAM and make it available to one of the other virtual machines. Now, before we go on, there are several different types of virtualization that you need to be familiar with. The first type is called full virtualization. In full virtualization, the virtual machine completely emulates a real physical host. And this is really good because it allows most operating systems and applications to run within that virtual machine without being modified in any way. Another form of virtualization is called partial virtualization. In partial virtualization, some components of the virtual machine are virtualized, but some are not. In other words, the operating system uses some virtual components and some real physical hardware components and the actual device where the hypervisor is running. Now, it's important to note that an operating system can only run in a partial virtualization environment if that operating system or application has been specifically modified to do so. And the last type of virtualization is called para-virtualization. In para-virtualization, the hardware isn't virtualized at all. In other words, all of the guest operating systems running on the hypervisor actually access various hardware resources in the physical devices directly. It doesn't virtualize any of the components. To do this, the guest operating systems run in isolated domains on the same physical hardware, which basically simulates running on separate systems. For an operating system or application to run a para-virtualization environment, the operating system or application has to be specially modified. As you can see, the hypervisor is the key component in any virtualization environment. There are several different hypervisors you can choose from. Let's take a look at some of the most commonly used ones here. One of the more commonly used VMware hypervisors is called VMware Workstation. As its name implies, it's not really designed for a server environment where you're virtualizing production servers. Instead, it's designed to be used on top of a Windows or Linux workstation. It allows you to do most of the things that you can do with any other hypervisor, but the purpose behind it is a little different. Basically, it's designed to allow you to install lots of different operating systems and test them. This is commonly used by app developers. If you're developing something that needs to be runnable on the Linux and Windows operating systems, you can set up a Linux and a Windows OS using VMware Workstation and test your application. Workstation also works great for developing demonstrations or developing training and so on. VMware also makes the ESXi and ESX hypervisors. These are designed specifically for the data center. They're designed to host virtual servers that will provide network services in a production environment. The only difference between these two is that ESXi is a pared down free version, whereas ESX is the full-blown version. Microsoft provides their own hypervisor as well, and it's called Hyper-V. If you install Windows Server, then you can install the Hyper-V hypervisor right from your installation media. It's a fantastic hypervisor. There's also an open source hypervisor called Xen. A lot of Linux distributions include Xen. Another popular open source hypervisor similar to VMware Workstation is VirtualBox. It's available for Windows, OS X, Linux, and Solaris workstations. All of these hypervisors perform basically the same role that we've talked about before, allowing you to install multiple operating systems on the same piece of hardware. That's it for this lesson. In this lesson, you were introduced to the role and function of virtualization. We discussed how virtualization works, and we discussed the benefits of virtualization. Then we ended this lesson by discussing the different hypervisors you can use for virtualization.